Hello everyone, I welcome you to my channel, and this will be lesson 2 for indefinite integral, and here we are going to learn some very important and basic questions on indefinite integral, and these questions I'm sure that it will be help you for your preparation for your exams, okay, in class 12. And for today's, this is question 11. We'll be starting from question 11 because the first 10 questions you have done in lesson 1. Okay, so it's this question number 11. Just we need to evaluate that sin to the power 4x by cos to the power 8x dx. That questions are basic question, as I said, simple and okay, and we'll just keep solving, and if you like solve yourself, right, and you can see the question, and if you can solve along with me, then it will definitely help you a lot. Okay, and so we'll just start with this question 11. Okay, let I, okay, I is equal sin to the power 4x and cos to the power 8x dx. First we are going to simplify this. So what I'm going to do is we'll just divide both numerator and denominator by cos to the power 4x. Okay, so what the advantage we get if we divide sin to the power 4x by cos to the power 4x, we just get 10 to the power 4x. And in case if we divide cos to the power 8x by cos to the power 4x, okay, we'll get as cos to the power 4x will left out, okay, dx. So that next steps we can just write in this way, that 10 to the power 4x and this 1 by cos to the power 4x can be written as sec to the power 4x dx. Now just the simple steps, it's obviously it will follow that if we substitute 10x, right, if we substitute 10x is equal to t, then differentiation of 10x gives us sec square x equal dx equal to dt, right. So that means we need a sec square x. So we can do one thing, we can just write 10 to the power 4x, okay, then from there we can just write sec square x into sec square x dx. Done. Okay, now let's go for this substitution, 10x equal to t, sec square x dx equal to dt. So this 10 to the power 4x can be written as, okay, it can be written as t to the power 4, because 10x equal to t, so 10 to the power 4 it can be written as t to the power 4. Now sec square x can be written as 1 plus, we know that sec square x is 1 plus 10 square, so we can just write 1 plus t square, and sec square x dx can be replaced by dt. Okay, I was saying that steps are very simple now, that 10 to the power 4 into 1 plus t square dt. Okay, let's just multiply now. Next we'll multiply. Okay, just if we multiply this steps, 10 to the power 4 into 1 plus t square dt, so we can just get this, that is t to the power 4 plus t to the power 6, okay, dt. T to the power 4 plus t to the power 6 dt. So we'll just start integrating now, and if we integrate this, okay, if we integrate this, so t to the power, okay, it gives us t to the power 5 by 5 plus t to the power 7 by 7 plus 6. Those steps are as simple as this, and we can just substitute 1 by 5, t values is equal to, we substitute t is equal to 10x, so it's 10 to the power 5x plus 1 by 7, 10 to the power 7x plus c. Done. So this is question 1. Okay, so what we have done, just we are dividing numerator and denominator by cos square cos to the power 4x, and it gives us 10 to the power 4x, and this cos to the power 4x we are just bringing up, that is 10 to the power 4x 6 to the power 4x, and then 10 to the power 4x is living like that. 6 to the power 4x is expressing in the form of sec square x into sec square x, and then we did substitute 10x equal to t, so t to the power 4 and sec square x can be written as 1 plus t square, that means 1 plus 10 square x, so 1 plus t square dt, and I hope that remaining steps obviously will follow. So this was question number 1. Okay, we can just move to the next question. Okay, this is question 12. Okay, this is a question from the NCERT. Okay, so how to solve this question? To solve these questions, so just see that if we substitute 10x equal to t, 10x, okay, let 10x equal to t, then this gives us sec square x dx equal to dt, right? If we just see these steps, 10x equal to t, sec square x dx equal to dt. But you have seen that there is no sec square x there in this questions. So you can do one thing, you just can manipulate the steps. So how to manipulate this? So this steps will leave as it is, root 10x. Just trying to manipulate the denominator. So I just need to introduce sec square x in the numerator. You need a sec square x in the numerator. So you need to make cos x cos square x, right? That is our objective. We're just going to make cos x cos square x. So how can you do that? So for that, you can divide sin x by cos x. Then you can just multiply cos x. So it will be cos square x. So I think this steps is very important for this question. Okay, so just got a hint from this function 10x. The moment you substitute 10x, so the differentiation of 10x gives us sec square x dx. We have seen that no sec square x there, so to at least the cos x is there. So you can just think of like to create a function cos square x in the denominator, so that just you can just bring it up to make it sec square x. Okay, that's what we have done is we're just dividing this function by cos x, it's sin x by cos x, and if we divide you need to multiply. So cos x we are multiplying by cos x, so it's cos square x, right? This is cos square x. Fine. Now what's the next steps? Next steps is root 10x. Fine. So it's 10x. Now this one will just go up. So it will be sec square x dx. Now already we have just assumed that 10x equal to t. So just go for the steps. Okay, and I can of course cancel it. Okay, we will cancel next steps. This is root t sec square x dx to be dt. Fine. Now what's the next step? Root t by t. So you can just cancel t by root t. So it will be 1 by root t, 1 by root t dt. Right? If I just cancel this, 1 by root t into dt. Fine. So this is almost done. So it's a direct formula. You can just write the answers. Okay. And this question is simple, but this has got one simple trick, nothing else. Okay. Then 1 by root t dt is 2 root t plus c. So this gives us 2. T is 10x. 10x plus c. So answer is as simple as this. Okay. Now just can move to next question. That find the value of integration of dx by x squared x to the power 4 plus 1 to the power 3 by 4. How to solve this question? Okay, to solve this question, we can just start with this. What I'm going to do is dx, find x squared, we just see this function. From there, from this, just going to take x to the power 4 out. So if you take x to the power 4 out, x to the power 4, that is 4 multiplied by 3 by 4. So just it will be x cube outside, like, okay. So and if I take x to the power 4 common, so first term will be 1 and second term will be x to the power minus 4. Done, right? We are taking x to the power 4 out. So this exponent will be multiplied by 3 by 4. 4 cancel out. So that means like you can take x cube out, right? Then the power will be as it is, 3 by 4. So this gives us what? Dx x5 1 plus x minus 4 to the power 3 by 4. I think the moment you start with the steps, so remaining steps will be definitely very simple. I'll just go for our substitutions now. What are we going to substitute? Just substitute this. So if you go for the substitutions, let 1 plus x to the power minus 4 equal to 3. Let's see the differentiation of this. So if I just substitute this, so this gives us minus 4 x to the power minus 5 dx is equal to dt. That means minus 4 into dx x to the power 5 is equal to dt. So have you seen dx by x5 terms? Here also dx by x5 term is there. That's a benefit. Like the moment you substitute 1 plus x to the power minus 4d equal to t. We're just going to substitute a value of t now, right? So what is dx by x5? dx by x5 is dt by, so this minus 4. Okay, you can transpose to that side, so dt by minus 4. We just can write minus 1 by 4 dt, right? We'll just write in place of dx by x to the power 5. Now this is equal, this can be replaced by t value. So it will be t to the power 3 by 4, done. T to the power 3 by 4. We can just next simplify this expression. Okay, we can just simplify it this way. Fine. We can take 1 by 4 out, right? Minus 1 by 4. So we can just bring it up, t to the power minus 3 by 4 dt. So having these steps are very simple. The moment you just take x4 out, now minus 1 by 4. So this will be t to the power minus 3 by 4 plus 1 minus 3 by 4 plus 1 plus 3. Okay, this is minus 1 by 4 and this gives us t to the power minus 3 by 4 plus 1. This gives us t to the power 1 by 4 and denominator also same, 1 by 4 plus c, right? 1 by 4 plus c and this 1 by 4 and this 4 and this 1 by 4. You can cancel this, right? You can cancel. So this answer is minus t to the power 1 by 4 plus c. Okay, this is the answer. T value. Then what is the value of t? T value you did substitute, that is 1 plus x to the power minus 4. This is 1 plus, so minus is there, minus will be there. You can just write a minus sign there. Yes, minus t value 1 plus x to the power minus 4 to the power 3 by 4 plus c. Done. Okay, so this is a very simple answer. Okay, we can just move to, okay, just take in other questions, like evaluate that cos to the power 7x dx when for an indefinite integral, right? When relatively higher power of trigonometric functions are there. So how to solve like these questions? So just can try for this. That is, say we just write cos to the power 6x into, okay, cos x dx. Fine. So just try for substitutions. It may obviously it will come to your mind that okay, cos to the power 7x dx is there, so we don't have a direct formula for cos to the power 7x. So just try to go for either by some manipulations or by method of substitutions. So we just can write cos to the power 7x is cos to the power 6x into cos x. Now in case cos x will write in terms of sin x, so you can just go for method of substitution. So cos to the power 6x can be written as, okay, you can just write 1 minus sin square x. So what is 1 minus sin square x? Cos square x. So if you write 3, so it's cos square x to the power 3, it's cos to the power 6x. So cos to the power 6x can be written like that, and cos x dx. Done. Let's go for substitutions now. Okay, so what is the substitutions? We will substitute sin x is equal to t. Why? Because if you substitute sin x equal to t, differentiation is cos x. So let sin x equal to t. Okay, and therefore cos x dx gives us dt. So it's almost like if you come to this steps, so almost it's done. So see that remaining steps, 1 minus sin x is t, so it's t square. Fine. Sin x equal to t is t square q. And cos x dx gives us dt. We'll expand now. Okay, by a minus b whole key formula, it's 1 minus 3 t square plus 3 t to the power 4. Okay, plus this will be minus, of course, it will be t to the power 6 because it's b cube. Okay, this is 1, 3, that 1 square into b, like plus 3 and 1 into b square, t to the power 4 minus 3 to the power 6 is dt. Okay, we'll just integrate now. Okay, this we'll integrate and substitute the value of t. Okay, we'll just integrate. How to integrate this? So the first one, this is t minus 3 into t cube by 3. Then the next step is what? That is 3 into t to the power 4 by, so it will be t to the power 5. 3 t to the power 5 by 5, fine, and it will be t to the power minus, okay, t to the power 7 by 7 plus c, done. Okay, next 1 t, and this is t cube by 3 plus t to the power 5 by 5, okay, now minus t to the power 6, this is t to the power 5, okay, this will be t to the power 5, then minus t to the power 6 integration t to the power 7 by 7 plus c, and what we need to do is we need to only substitute the value of t. T you did substitute what? T you did substitute sin x, so it's sin x and it will get cancelled out, fine, it will be sin cube x plus 3 by 5 and substitute the value of t, that is sin to the power 5x minus 1 by 7, t value sin x, sin to the power 7x plus c, it's done. Okay, fine. So the steps are as simple as this. Okay, now next, let's take another questions. Okay, dx by sin x minus alpha into x minus beta. So how to solve these questions, right? To solve these questions, just follow a simple trick. Okay, sin x minus alpha into sin x minus beta. We know like direct formula, it's not there. And in fact, we cannot solve this with the help of the substitution right this moment. So what we are going to do is, we're just going to manipulate this whole function, right? This whole expression. How to do that? So, simple trick is, see this is alpha, this is beta. Okay, just in the numerator, it's trying to introduce the term sin beta minus alpha. We can just obviously write sin beta minus alpha, and at the same time, what I'm going to do is, we just divide by 1 by sin beta minus alpha, because this is constant. We are introducing, we are multiplying a numerator by a constant, and similarly you can multiply the denominator also. Sin beta minus alpha. Beta minus alpha on this, the reason is with sin one constant is there, with the second sign another constant is there. We're just trying to write sin beta minus alpha. Okay, this is step 1. Now denominator will read as it is. X minus alpha sin x minus beta. Fine. Sin x minus beta dx. The reason behind introducing this, you will understand now. This sin beta minus alpha, this beta minus alpha, we just need to write in terms of x minus alpha and x minus beta. So how can you write this? 1 by sin beta minus alpha. You can just write this expression in the form of this, right? I'll show you this. How can you write this? Okay, so you can write x minus alpha, fine, x minus alpha, then minus x minus beta. So can you just write in this way? Instead of sin beta minus alpha, can I write? Because our intention that beta minus alpha need to write in terms of x minus alpha, x minus beta. Okay, so can you write like this? X minus alpha, because we don't need x there. So if you are writing x, therefore there should be a minus sign, so that both x will get cancelled out. If you write minus alpha, it's fine, because we need minus alpha. And if you write beta, it should be plus. So therefore it's x minus beta and x minus beta, this minus minus will get cancelled out. So finally, it actually nothing but this sin x minus alpha minus x minus beta is actually nothing but sin beta minus alpha. Okay, now sin x minus alpha sin x minus beta. Fine. Is it okay? Right? Only just we are multiplying the numerator denominator by this term sin beta minus alpha, and this beta minus alpha we just expressing in terms of these two angles, that is x minus alpha and x minus beta, and the remaining steps I think you will obviously follow. So how to go for the next steps, what to be done for the next steps? This is sin A, this is sin A minus B. So I'm just going for sin A minus B formula. So just 1 by sin beta minus alpha. Okay. Then denominator, we're just not going to do anything with the denominator right now. It will be sin x minus alpha sin x minus beta. Fine. We'll just write sin A minus B formula. This is sin A cos B, cos x minus beta, sin A cos B minus cos A, that is x minus alpha, okay, sin x minus beta. Fine. Sin A cos B, cos A sin B. This is sin A minus B formula. Now, what you need to do is, next, so each and every term, these two terms you are going to divide by the denominator. So this will definitely simplify your question. Okay. So if you divide this by this, sin x minus alpha will get cancelled out. It will be cos x minus beta by sin x minus beta. This gives you cot x minus beta. Fine. Similarly, if you divide this one by this, so sin x minus beta will get cancelled out. You will get cos x minus alpha by sin x minus alpha. So that gives you cot x minus alpha. Okay, dx. Is it okay? Like you are dividing this one by this. So this first, these two terms will get cancelled out. Cos x minus beta by sin x minus beta gives you cot x minus beta, right? And here you are dividing this one by this. So here sin x minus beta and sin x minus beta. This will get cancelled out, right? Cos x minus alpha and by sin x minus alpha gives you cot x minus alpha. We are going to integrate now. So we know that this is standard integrations and we know how to integrate cot x minus beta. So what is the integration of cot x dx? What is the integration of cot x dx? We know that integration of cot x dx is log sin x. Okay, this is log sin x, integration of cot x. But therefore, this integration of cot x minus beta is log sin, okay, x minus beta. Fine. And minus, it's log, okay, x minus alpha, cot x minus alpha, log sin x minus alpha. Then log, so it's a both sign. Fine. Plus c. So it's almost done. So you just can write one simplified steps with the help of log a minus log b. You can just write log a minus b formula. Okay. So just can want to simplify these answers. You can write the simplified form in this way. Is equal to final answer will be 1 by sin beta minus alpha. Okay. You can just write this is log sin x minus beta, fine, sin x minus alpha more plus c. So this is the answer for these questions, and this question is a very important question. Okay, and if you just practice the trick, okay, that how to manipulate the steps and what terms to be multiplied in the numerator denominator, and obviously you will not have any problem in solving such questions. Okay, so just move to next questions now. Fine, this is find the value of 1 by x into x to the power 7 plus 1 dx. Okay, how to solve these questions? It's okay. Before I solve this question, just one simple hint for these questions. The moment the expression in the form of 1 by x into x to the power 7 plus 1, say if the form is this pattern, that is 1 x to the power n plus 1, this form. Okay, then what you need to do is you need to multiply both the numerator and denominator by x to the power n minus 1. Remember this, you just need to multiply both numerator and denominator by x to the power n minus 1. So in this case, we'll multiply both numerator and denominator by x to the power 7 minus 1, that is x to the power 6. So if you multiply, it will be x to the power 6, and if you multiply the denominator by x to the power 6, and x to the power 6 gets multiplied by x, so it's get x to the power 7 and x to the power 7 plus 1. The rest is very, very simple. Okay, so what we are going to do is, okay, just we are going to substitute 1 plus x to the power 7, right? We will substitute 1 plus x to the power 7 as t. Okay, let 1 plus x to the power 7 is equal to t. Fine. So if you substitute, it will 7x to the power 6 dx equal to dt. That is, if you differentiate this will be 7x to the power 6 dx equal to dt. So let's see this. So if x to the power 6 dx, x to the power 6 dx gives you what? 1 by 7 dt. Right? It gives you 1 by 7 dt. Now x to the power 7. What is the value of x to the power 7? X to the power 7 x to the power 7 is equal to t minus 1. Right? It's t minus 1. So what is x to the power 7 plus 1? It's t. Right? If you substitute x to the power 7 plus 1 is t, so x to the power 7 gives you t minus 1. Fine. So what's the next step? dt, that is t into t minus 1. Fine. So at this point, like you cannot integrate this function, that is 1 by t into t minus 1. Okay, we'll just simplify this function and we'll just integrate it. Okay, how to simplify this? Okay, to simplify this 1 by t into t minus 1, just we're going to learn in the next video, that is in the form of partial fractions. Alright, now these questions, since the function is very simple, okay, without knowing that concept of partial fraction, we can actually write this expression 1 by t into t minus 1. You can just write as a sum of two simple functions. Okay, how can you do that? So if you write this, okay, 1 by t minus 1 and okay, 1 by t. Let's see what do you get. If you just write this as a sum of these two functions. Fine. So sum of these two functions, it should be 1 by t into t minus 1. So it has to be, this t should get cancelled out, it has to be minus 1. Let's see what do you get. Right? So if you take LCM, it's t into t minus 1. So it's t and it's multiplied by. So if you take the LCM of this, it is t minus 1, and the numerator is t minus t and plus 1. So it's get cancelled out, we get 1 by t into t minus 1. So that means 1 by t into t minus 1 actually can be written in the form of 1 by t minus 1 minus 1 by t. Now compare these expressions. At this point you can integrate these functions. The moment you are expressing this function, this is a rational function as a difference of two simple functions. Okay, two simple rational functions, then these functions are easily integrable. Okay, so how to integrate this? 1 by 7. What is the integration of 1 by, you can just integrate 1 by t minus 1 dt. Fine. Then write one step, 1 by t dt. So 1 by 7. What is the integration of 1 by t minus 1? It's log t minus 1 and minus log t. Okay. Plus c. Done. So you can just write this 1 by 7 log t minus 1 by t plus c, and you can just finally substitute the value of t. Okay, t you substitute as x to the power 7 plus 1. Okay, let's just substitute the value finally to get the answer. Okay, you can substitute this, that is 1 by 7. Okay, log x to the power 7 plus 1. Okay, x to the power 7 plus 1, that is x to the power 7 plus 1 equal to t. Fine. So t minus 1 is equal to x to the power 7. So you will get, this is x to the power 7 and this is t. T value is x to the power 7 plus 1 plus 3. So finally you will get these answers. So t minus 1 is equal to, gives you x to the power 7 and t value is x to the power 7 plus 1 plus c. So this is the method, right? Okay, and let's move to next questions, that is the value of integration of 5x plus 3 under root x square plus 4x plus 10 dx. So how to integrate these functions? Okay, to integrate these functions, first of all, these expressions, that is numerator. So numerator will be writing in the form of, okay, let 5x plus 3. Okay, 5x plus 3, then a, then we'll just differentiate this. A constant, A is a constant, we'll differentiate this expression, this polynomial x square plus 4x plus 10. So if you differentiate this, this is twice x plus 4, and just write b. Okay, this if an integral of the form, okay, px plus q, then ax squared plus bx plus c dx. So to integrate such questions, first of all, this numerator, that is px plus q, is written as a into ddx of this polynomial. Okay, ax squared plus bx plus c, then you just write a constant. Now after differentiation and comparing terms, we'll just get the value of a and b. Okay, then we'll just substitute and we'll go for the integration of this type of equation, right? So similar way that this expression, this numerator is a constant, differentiation of this x squared plus 4x plus then b. Now let's compare now. If we just compare the comparing, okay, we'll just comparing the coefficient. Here the coefficient of x is 5. So from the right hand side also, we'll just compare the coefficient of x. So what is the coefficient of x? X coefficient is 2a. 2a, fine. So therefore, a is equal to 5 by 2. Fine, you got the value of a, right? That coefficient of x is 5, right hand side, like has coefficient of x in only one term, that is twice x. It's multiplied by a, twice a. So that coefficient of x is twice a. So twice a is equal to 5. So this gives us a equal to 5 by 2. Then we'll just compare the constant term. Okay, yeah, and if you compare the constant term, this is 3. And what is the constant term there? This is, if you multiply a with 4, it's 4a plus b. Now you got the value of a already. This is 3 equal to 4 into a. A is 5 by 2 plus b. So you can cancel this. This is equal to 3, 5 to the 10 plus b. Fine. So this implies b is equal to minus 7. So with the help of these simple steps, you got the value of a and you got the value of b, right? Or just a value is equal to 5 by 2. Okay, a value is equal to 5 by 2 and b value is equal to minus 7. Then we'll just go for the other steps. Okay, this is the step 1 for these questions. Okay, we're just trying to just manipulate the numerator, because if this manipulation will help us to solve these integrations. Let I is equal, okay, 5x plus 3 and under root x squared plus 4x plus 10 dx. Okay, next, we're not going to change anything in the denominator, x squared 4x plus 10. Only thing is that this one already we have written in the form of this. The numerator we have written a into differentiation of this. What is the value of a? Is 5 by 2 and differentiation of this. So twice x plus 4. Okay, and plus b. Plus b is what? It's minus 7 dx. Fine. Now it's done. This 5x plus 3 actually can be written in the form of 5 by 2 twice x plus 4 minus 7. Now why you should write in this way, you'll understand in the next steps. Okay, the moment I write, I'll just separate this integral into two parts. This is 5 by 2. Okay, this is twice x plus 4. Then under root x squared plus 4x plus 10. Okay, 10 dx. Then next, this divided by this gives us first integral, and the second integral you can take 7 common. Then integration of, okay, dx under root x squared plus 4x plus 10. X squared plus 4x plus 10. Now let's go for the first integration. Let's see how to integrate this and what is the benefit of manipulating 5x plus 3 in this form. Now for this type of questions, the first integral always will be the method of substitutions, can be solved by method of substitution, because if you substitute x squared 4x plus 10 as t, then differentiation of x squared plus 4x plus t actually twice x plus 4, because that x squared differentiation is twice x, 4x differentiation is 4. So if you substitute x squared 4x plus 10 is equal to t, so this will be t, this will be dt, so dt by root t. Okay, so let's go for one by one. First we'll integrate this integral. Okay, we can just integrate in this way, that is 5 by 2. Fine. First we'll just go for substitutions. So this is dt and this is root t. Now how did you substitute this? So we're just assuming let x squared plus 4x plus 10. Okay, x square 4x plus 10 equal to t. Then twice x plus 4 dx equal to dt. That means in place of twice x plus 4 dx, twice x plus 4 dx, just you can replace by dt. And x square plus 4x plus 10 can be written as t. So it's dt by root t. Fine. Minus 7. Remember this. These substitutions we have done for the first integral. And 7 integral to be done by different method. Okay. And how to solve the second integrations. Second integrations, it's obviously it's coming to your mind. Maybe this is to be done with the help of the standard integral that can be expressed. The denominator will try to express the sum of 2 square or difference of 2 square. How can you write this? So say x square plus 2 into a into b. So this gives you 4x. Now what is b here? 2. b is 2. Well, just write 2 square. Fine. So a square is this term. 2 into x into 2. This is this term. And 2 square is 4. So here is 6 is there. But you have written 4. So you can just write 4 plus 6 is 10. This 6 can be written as root 6 square. Can you write like this? Fine. So next. What is the next steps? Right? Next step is this. 5 by 2. Okay. dt by root t. It's a direct formula. It's log dt by root t. It's not log. It's 2 root t. Right? 2 root t. dt by root t is 2 root t. That is minus 7. And this can be, we just can express this expression, this polynomial in the form of x plus 2 whole square plus root 6 whole square. That is x square plus a square form. Okay, we know this is a standard form, x square plus a square. So finally we can just cancel this. This is 5 root t. Okay, t means x square. Okay, t is x square plus t value. Okay, t value we did substitute this, right? X square plus 4x plus 10. This is t. Fine. And minus 7. So I hope you just remember this integral, this standard form. That is integration of dx by under root x square plus a square. Okay, do you remember this? This is log x plus x square plus a square plus c. This is a standard integral, a very important standard integral. So here in place of x is x plus 2 is there. So still you can just use for this integral also you can use the same formula because differentiation of x plus 2 is dx. So this gives you log a. A means log x. X means x plus 2. Okay, plus x plus 2 whole square plus root 6 whole square. Fine. Plus c. Done. Okay, so we just instead of this one you can just write x square plus 4x plus 3. If you expand this one, this you will get the same expressions, right? So this is also a very important sum, and